All right, number 13, we're going to be using this same formula. So screen looks a little bit different. I started recording the last few and I didn't hit the record button. So I'm in practice, but it's the same type of problem. So we have a local diner started selling cupcakes using the chart below. They kept track of how many they sold each day, how many cupcakes will be sold on day N. So on the previous one, they gave us the day, like we were looking for the 14th day, how many will they sell on this day? Well, this time they're not telling us what the day is. They just want to know on day N, some arbitrary day, how many would they sell? And so we need a formula. And so we're going to be using this formula to figure that out. So we're going to be using this bar graph to write down the pattern. So day 1 goes out to 6. Okay, so I'm going to write this pattern down. So we got 6. Okay, day 2 goes out to 10. Okay, so day 3 goes out to 14. And day 4 goes out to 18. All right, so I need to find the common difference. It's 4 here, 4 here, 4 here, so it's consistent 4. All right, so now I'm going to use that pattern. So my first day starts with 6 plus 4, and then times n minus 1. So I don't know what n is, so I got to leave it like this. I'm going to solve this formula or simplify this formula as much as I can. So we're going to multiply by 4 or distribute the 4. 4n minus 4. All right, so distribute 4 times n, 4 times 1 minus 4. And then we're going to combine the 6 and the 4. So I got to do 6 minus 4. That's going to give me 2. So 4n minus 2 is what we get. Okay, so this is a formula. Now let's check it to make sure it works. So let's just say I want to see if it works on day 3. Okay, so I'm going to plug n equals 3. And I want to see, does that give me 14? So I'm going to take this 4. I'm going to do times 3. Minus 2, and see, do I get 14? 4 times 3, that should be a plus 2, sorry. 6 minus 4 is a positive 2. Plus 2, got to be careful. All right, 4 times 3 is 12, plus 2 equals 14. 12 plus 2 equals 14, and that's what I have on the right side, so it checks out. So on this problem, they're looking for just a formula. So 4n plus 2 is going to give us the number of cupcakes that will be sold on day N. So I'm going to do 4n plus 2. Go to the next. Okay, so this one, we want to select a counter example. That means something that proves the opposite of what the statement is saying. So this one says the sum of 2 composite numbers is always composite. Okay, so what is a composite number? What are they talking about? Okay, so there's 2 types of numbers we deal with. There's prime and composite. Okay, prime are those numbers that only have 1 in itself as a factor. So that would be 2, 3, 5, 7, 11. So it wouldn't be 9. It's not all the odd numbers. But every prime number after 2 is going to be odd. But not every odd number is prime. 15 we would skip. We would keep going. 17, so forth and so on. So these are prime. If it's not prime, it's composite. So that would be 4, 6, 8, 9, because 3 times 3 is 9, and 1 times 9 is 9, and then 12. So basically most of those even numbers, 14, and then 15. So if it's not prime is composite. So that's what they mean when they say composite, a number that has more than one multiple, more than itself and one as multiples, or more than two factors. And so we want to know the sum of two composite numbers is always composite. So if I add 8 and 9, they're both in here, that equals 17. 17 is not composite. So this will be a counterexample, okay, because this statement says two composite numbers is always composite. Not always. It is sometimes. If I do, which I skipped a number, 10 should be over here, but if I do 4 plus 6, that gives me 10. 4 and 6 are composite, 10 is composite. So sometimes it works, but there are cases where it doesn't work. So when it says it always works, you just find me one that doesn't work. So this one, two composite numbers that add up to be something that's prime. These two, composite, composite, composite. These two are all composite. 5 is prime. It doesn't even fit in the composite section. 3 is also prime. So this one adds two prime numbers and gives me a composite. So the only one that is a counterexample of this statement is A. Two composite numbers add up to give me something that's not composite. So A is the best choice. And then 15 is going to be our last one. It says use deductive reasoning to choose the correct conclusion. And it says, my teacher said the only way to get extra credit is to give a speech in class. I will not give a speech in class, so I will not get extra credit. Okay, because that's the only way to get extra credit. So that's the only thing that makes sense. All right, so that's going to be the end of 1.1.